So can I start?
Yes, ma'am. Please.
Okay. A very warm welcome to everyone and good morning to all. Myself, Jasleen Kaur, Assistant Professor in the Department of Pharmacology at Amar Shaheed Baba Ajit Singh Jujhar Singh Memorial College of Pharmacy, BELA. I feel truly honored to serve as the host for today's expert lecture and will be guiding you all throughout the session. Today's expert lecture is being organized on the special occasion of 51st Golden Jubilee celebration, a milestone that marks over 5 decades of excellence, growth, and academic legacy. Before we begin, I would like to take a moment to introduce our esteemed institution, Amar Shaheed Baba Ajit Singh Jujhar Singh Memorial College of Pharmacy, BELA, which is one of the premier institutes of Northern region. It was established in 1993 by a non-profitable society in the sacred memory of Sahibzadas Ajit Singh Ji and Jujhar Singh Ji, the sons of Guru Gobind Singh Ji, who sacred their lives at a young age. This institute has made remarkable progress over the last 3 decades and offer various programs including Diploma in Pharmacy, Bachelor's of Pharmacy, Master of Pharmacy, MSc Pharmaceutical Chemistry, MSc Microbiology, and Bachelor's in Medical Laboratory Science. An autonomous institution, COPBELA, is affiliated with IK Gujral, Punjab Technical University, Jalandhar, and is also recognized PhD research center in the pharmaceutical sciences. The college is accredited by NBA, recognized under UGC 2F, ranked 57th in NIRF 2024, and placed in the platinum category in the AICTE CII Industry Linkage Survey 2018 and 2019. Now, with great pleasure, I introduce today's expert speaker, Dr. Sant Kumar Verma sir, an accomplished academician and researcher with over 14 years of teaching and research experience in the field of pharmaceutical chemistry. Dr. Verma is currently serving as the Associate Professor and Head of Department of Pharmaceutical Chemistry and Analysis at ISF College of Pharmacy, Moga, an autonomous institution of great repute. Dr. Verma has made remarkable contributions in the area of drug discovery, computer aided drug design CAD, QSAR studies, molecular docking, and the synthesis of novel bioactive compounds. His research focuses on developing innovative and safe lead molecules, particularly for type 2 diabetes and its complications. He is the recipient of the Startup Research Grant SERBDST worth 20.66 lakh and MSME Idea Hackathon 2.0 grant of rupees 15 lakh for his pioneering work in plastic remediation and novel drug design. Dr. Verma's excellence in research is evident from his numerous publications in high impact international journals such as Journal of Controlled Release and European Journal of Medicinal Chemistry. He holds an impressive record of more than 67 international publications, 2 books, 1 book chapter, 10 seminars or workshops conducted, 2 FDPs, 2 CAD certificate courses conducted, and also supervised 32 MPharm and 5 PhD theses, along with multiple patents, including 1 PCT, 1 Indian granted patent, 28 Indian patent published, and 6 design patent granted. In addition to his research achievements, Dr. Verma also plays several key academic and administrative roles as the member of NAC Steering Committee and PCI-QCI Committee, coordinator of IPR Cell, and certified trainer for the Life Science Sector Skill Development Council, Government of India. His leadership in conducting training program, faculty development workshops, and certificate courses on CAD has significantly contributed to advancing pharmaceutical education and innovation. We are truly delighted to have Dr. Verma sir with us today. On behalf of our college and all present here, I extend a very warm welcome to you, sir.
Thank you, Jasleen ma'am, for a very nice introduction. Firstly, I wish to thank Amar Sahid Baba Ajit Singh Jujhar Singh Memorial College of Pharmacy and Autonomous College, BELA, for inviting me as a speaker for Golden Jubilee Celebration 51 online lecture series. So, I wish to thank Director Sailesh Sharma sir. Uh, may I start, ma'am?
Yes,
Yes,
sir.
yes, yes. So here, myself, Dr. Sant Kumar Verma, as introduced by Jasleen ma'am. I wish to elaborate about the application of a statistical tool in research methodology. So here, all of us use statistical tool in research methodology to compile the data analysis, as well as compilation of the result. This is a integrated part of all types of research, which is used in the biology, which is zoology, botany, commerce, medicine, education, physics, chemistry, biotechnology, psychology, and pharmacy. So, so basically, from at this point, I wish to discuss some important statistical tool which are used generally used in our research in pharmacy and pharmaceutical sciences research. These are some basics tools which we are going to use in our daily to daily research, like compilation of data for physics people, for chemistry people, for cognosy people, and all other branches. We are indulged in the animal study, in vitro study, and number of studies are involved, even drug release studies for the pharmaceutics. So we are using these terms. So I wish to elaborate these things. So firstly, I wish to elaborate mean. It is the average of data. We simply think that this is the mean, but mean can be represented in three form. This is mean, median, and mode. There are three different things, and the elaboration of these three things are different. So uh, I wish to elaborate these three things. First is the mean. Mean is arithmetic mean. The formula for arithmetic mean is it's denoted by x bar, and is the summation of all the numbers and numbers in the data set divided by numbers in the data set, then sigma xi divided by n. So if you can see, we are having an example, like we are having the drug content present in five different tablet samples, that is 98.2, 99.1, and 97.8, 98.5, and 98.9. The mean will be the summation of all these five value, and divided by with the number of tablets, that is we are having five tablet divided by five. The mean will be 98.5. So what does it denote? So it denotes the overall trends of a data set, or providing a rapid snapshot of your data. Suppose we can see that we are having 98.5 mg, the average value or mean value, means all the five values are around this 98.5, some value less or some value greater. We are near about 98.5. So how we are going to calculate in Excel this value? Simply we just put all the value, and uh, apply the formula average, and select the data from first to five, that is 98.2 and to 98.9, and press enter. We will get the value average. This is another aspect of my presentation, that I am just elaborating these things on simple Excel, so you can get some idea or calculate these things using Excel in a simple way. The second thing is median. It is a middle value. We have to arrange the data either in ascending or descending order. It represents the central tendency of data. After arranging the data in ascending or descending order, we have to take the central value. For odd number of data set, it is easy to take the central value but for even data set, suppose we are having five uh, five numbers in a data, then we can select the middle value, that is third one. But it is difficult to select the middle value for even number of data points. Then we have to take this central two value and take their average, the formula will be for odd number of series, it will be n plus 1 by 2, and for even number of series n by 2 plus n by 2 plus 1 divided by 2. For example, if we are having the odd number 4, 5, 6, 8, 8, 9, 23, the middle value is 8. That is the fourth value. For even number of series, we are having four numbers 2, 3, 4, 5. We have to sum up 3 and 4 and then divided by 2. The value will be 3.5. In first case, the median will be 8, and thus in second case, the median will be 3.5. From Excel, how we can it calculate? We have to apply median for all five datas, and in other case, we are having the even number, then apply for the even number. So we have to select the formula for even and as well as odd. In Excel, it automatically takes the value based on the even and odd number. So next, the parameter is mode. Mode, it represents the value which is most frequently occur in the data, uh, or which is present maximum time in our data. For example, like we are having the numbers, we can see that from 12, 14, 16, 18, 26, 16, 20, 16, 11, 12, 16, 15, 20, 24. We have to arrange similarly in like in median, we have to arrange the data in ascending order. Then we can see that 16 comes at maximum time in this series. Then the mode value will be 16. For data like we are having a series, like we are having a class interval 2 to 4, and the frequency of is 7, and 4 to 6, and 6 to 8, the frequency is 8. The class interval may be in case of time interval, weight interval, other things may be, and the happening of that class interval, yeah, instances of that class interval will be the frequency. So we have to select the model class. In this case, the maximum frequency class will be the model class, like 8. 8 is correspond to 4 to 6 class interval. Then 4 to 6 will be the model class. Then we have to apply the formula L plus H, Fm minus 1 divided by Fm minus 1 plus Fm minus 2. From this presentation, you can be able to get some basic formula, like we apply direct ANOVA, T value, regression value, but we are unable to know that what is the concept behind that values, from where that value comes. So from this lecture or this presentation, you can be able to get that from where these basics value come, what is the concept behind these values, and how we can calculate this value manually instead of using some tools, some application. We can simply calculate them on Excel. So for that grouped data, we have to apply this formula. L represents the lower limit of model class. We are having model class 4 to 6. The lower limit will be 4, and the higher H is the size of class interval. So H 4 to 6 size is 2. Fm is the frequency of the model class. F1 is the lower frequency, F2 is the higher frequency. So we have to apply the formula. Then L is 4, H is 6 minus 4, 2 class interval. Class interval size is 2. The class interval size is 2. FM frequency of that class is 8. Lower frequency below that model class is 7. We can see that below this class, F1, below this class, lower frequency is 4.42 to 4, the frequency is 7, and the frequency of higher class, that is 6 to 8, will be 4. After applying the formula, we can see that the mode of the this data is 4.4. So we can now distinguish between the mean, that is average value, median, that is the central tendency, and the mode. In Excel, we can apply the formula mode single and mode multiple. We are having, suppose we are having a data in a single series, we can apply the formula mode single and mode multiple. In the case of grouped data, we can apply the formula mode multiple. Here is another important term, that is the standard deviation. It is a measure of spread of data around the mean. From mean, the data is in what extent the data is deviated in plus and minus. So a high standard deviation signifies that data is spread more widely from the mean. Means if we are having higher standard deviation, means data is deviated more from the mean value. If we are having the lower standard deviation, means the data is less deviated from the mean or average value. The formula of SD, it is represented by sigma, and the formula is uh, summation of difference of a particular value minus mean of the data whole square and the summation, and this is multiplied by 1 upon n minus 1. N is the number of values in the data, and we have to take the under root of whole. So from one example, we can see we are having 8 vials, and the active concentration of in these 8 vials is 5.01, 4.98, 5.10, and so on. The unit is mg per ml. So we have to write, we have to calculate the standard deviation on the of this data. What is the standard deviation of this data? Then this value of x will be uh, given value, that is 5.02, 4.98, 5.10, and continued up to 5.03. Then we have to calculate the difference between the individual value minus the average value. We are going to calculate the average value of this data. Average value, summation of all the values divided by 8. The value will be 5.018. So the average value is 5.018. So we have to subtract the individual value from the average value. We can get the D value, and we have to take the square of this D value. This will be the D square. Then we have to summation. We have to apply the summation of these value. This is the value of D square. We have to sum these value. Then we have to calculate the variance, that is summation of D square divided by n minus 1. So n is the 8, and we have to subtract 1. Then we will get 7, and the summation of D square is 0.01789. After dividing with 7, we can get the value 0.00256. This is the variance value, and after taking the under root of this variance, we will able to get the value of standard deviation. The standard deviation will be 0.0506, means the average value is 5.018. The data, we can see the data is deviated plus minus from this value. Plus minus what value? 0.0506 from mean value, that is 5.0188. So this is the standard deviation. Every time we have to calculate in our animal study, in where we are having experiment in replication, we have to calculate the standard deviation from mean. We have to calculate the deviation of the data from mean value. What is the deviation of the data when we are having experiments in replicate? Calculation in Excel, we have to apply the formula. We are having basically two types of standard deviation in Excel, that is STDV P based on the entire population based on a sample. If we are having a sample data, or if we are having population, then we have to apply standard deviation P, or for a sample we have to apply a standard deviation S. we can directly apply and select the data, then press the enter, we can get the standard value. Another term is the standard error. So from a standard deviation, we can calculate the standard error. So we can see if anyone ask which value would be greater, a standard deviation for a data, standard error. Then we have calculated the standard deviation earlier, and a standard deviation divided by under root n. N is the sample size. Obviously, standard deviation will be greater compared to the standard error. This is the standard error formula, SD divided by under root n. N is the sample size. There is we can see there is a difference between standard deviation and standard error. Standard deviation measure the dispersion of individual data point with a single sample, or we can see the deviation from the average value of that data point. While the standard error measure the precision of the sample mean as an estimate of the true population mean, indicating the variability of sample mean from the multiple repeated sample. Another term is the regression. For the analysis student, they usually prepare the standard curve to determine the concentration of unknown sample using UV. We can also draw a standard plot using HPLC. So here we usually draw the curve between the concentration and absorbance in UV. So we can get the value we can correlate the dependent variable with the independent variable. I wish to elaborate this dependent and independent variable here. Dependent variable, which is depend on the independent variable. So in case of y is dependent on the x. So then y in linear equation, y is equal to mx plus c. Y will be dependent variable and x will be independent variable. Means it is the integral property of that particular substance, like concentration. X will be concentration and y will be the absorbance. When we increase the concentration, absorbance will be increases. So we can get the linear equation y is equal to mx plus c. So how we are going to calculate this regression? We just apply in Excel. We put the value of x and y and select the value and put the scatter plot, and we get the regression value y is equal to mx plus c. But manually, what is the concept behind this y is equal to mx plus c? How we are going to calculate this? So we have to put the value of this concentration 2, 4, 6, 8, 10. We are having the 5 concentration and corresponding absorbance is mentioned with the y, that is 0.5, from 0.5 to 7.4. So we are having value x and y. We have to multiply this x and y and calculate the value of x square. This table denotes the four value of x and value of y and value of x, y and value of x square. Then we have to calculate the summation of x, summation of y, summation of x into y, and summation of x square. And we are having number of data points, that is 5. We are having 5 data points. Then what will be the regression equation? How we are going to calculate the slope? The formula of slope is equal to n into summation of x, y minus summation of x into summation of y divided by n into summation of x square minus summation of x ka whole square. So from this we can get this value on the basis of above table. By putting this value, we can calculate the slope of this equation will be m value will be 0.075. What will be the intercept? The formula of intercept will be summation of y, that is the dependent variable, minus m we get 0.0745 divided by n. With this equation, we can able to get the slope. The slope will be 0.001. From this equation, we can be able to put the value y is equal to m. Now we have calculated m, that is 0.0745 x plus 0.001. This is the intercept. Suppose we are having some unknown concentration, and now the task is to calculate the concentration of that. So we have to take the absorbance of that sample and put the absorbance of that sample in this equation. Now we can get the this unknown concentration from this equation, y is equal to mx plus c. So from this regression, we can be able to calculate the slope, intercept, the concept behind the slope and intercept, how we are going to calculate the slope and intercept. From not only this, we can get the idea from this equation that by increasing the x square and uh, the difference of summation of x square minus x square, this value, that is the numerator value, we can get the lesser slope. If we have to increase the value of slope, we have to increase the value of denominator. So from this we can get this idea. Suppose we have to increase the intercept of that line which is cutting this y line. So we from this, if we are increasing the number of sample n value, the intercept will be less. From this equation, we can get the idea of slope, intercept, and also we can calculate the one dependent variable, one dependent variable, value of dependent variable. In case of this, the value of dependent variable is y, absorbance. Regression may be linear or multilinear. If we are having, suppose we are having one independent variable, then one independent variable in equation, this regression will be linear. Like y is equal to mx plus c. I have put this equation in the form of y is equal to a plus bx. Y is equal to dependent variable. Dependent means the value of y is going to depend on the x independent. Why it is independent? Because it is the integral property of that particular data point, that particular thing, that particular sample. In case of here, this the concentration of that we are having concentration on x-axis. X is the integral property. A particular solution is having a fixed concentration, so it is not variable. We are having suppose we are having 2 microgram per ml, then it will be fixed on 2. It is not variable. Variable is the absorbance, which is variable with the concentration. If you increase the concentration, absorbance will increase. If you decrease the concentration, absorbance will decrease. Then so a simple linear regression, y is equal to mx plus c. Multiple linear regression, where we are having number of dependent variable like x1 and x2. So this is called multiple linear regression, where the equation will be y is equal to a plus b1 x1 plus b2 x2 plus so on. The equation will end up to the number of dependent variable, that is x. From this equation, we can get the idea of linear or multiple linear regression. Suppose one dependent variable y is dependent on one variable, then it is simple linear equation. And if it is going to depend on two variable, it is multiple linear regression. Suppose in one experiment, we are having concentration 10, 20, 30, 40, and 50. Obviously, the concentration is going to depend on the temperature and the solubility. So we are having two variables, that is temperature and the solubility. Then it will not be a simple linear regression, it will be a multiple linear equation. It will follow y is equal to a plus b1 x1 plus b2 x2. So we have to individually calculate the value of b1, that is the slope, then b2, that is the slope for this variable. If we are going to calculate, the slope will be 0.4 from the above equation, and for b2 will be the 0.3, and a from the formula of intercept will be the 0.5. The equation will be 0.5 plus 0.04 x1 plus 0.03 x2. Suppose we are having a unknown, we are having a concentration, unknown concentration. Yeah, we have to calculate the unknown data from this equation. So we can calculate the y value of concentration if we are having x1 and x2. If we have y value, we have to calculate x1, either x2, then we can calculate both of values from this equation if we are having one unknown value. So this is the application of this. We can calculate the dependency of this concentration on temperature as well as the solubility. This is the multiple linear regression example. So, being medicinal chemist, I have to explore this statistical parameter in QSR. QSR is nothing quantitative structure activity relationship, where we get this equation in the form of multilinear regression. In the form of multilinear regression, that is is dependent on the biological activity is dependent on the different parameter, like properties of the molecule. It may be log p, it may be molar refractivity, it may be molecular weight, some other parameter. The parameter will be 2D and 3D. Based on these parameter, the QSR will be 2D or 3D. Biological activity is the uh, dependent variable on the independent property. Like we are having independent variable, that is molar refractivity and log p. Both these values is independent. Why independent? Suppose we are having one molecule. For one molecule, the molar refractivity is not going to change. For one molecule, the log p is not going to change. Then it is independent variable, and the biological activity is going to depend on this molar refractivity and log p. So then biological activity will be the dependent variable. So these statistical parameter, or suppose we are going to perform a QSR is nothing. We have to correlate this biological activity, that is dependent variable, with the properties of the molecule, with the form of a multilinear regression, Suppose I am going to say that I am very smart. Then how I will be smart? जब तक कोई सामने वाला ना बोले, जब तक कोई दूसरा ना बोले, जब तक कोई इस चीज को वैलिडेट ना करे, तो मैं कैसे स्मार्ट हो सकता हूँ? जब तक कोई दूसरा इस चीज को वैलिडेट ना करे। तो जो आपने क्यूएसआर परफॉर्म किया, जैसे दिस क्यूएसआर इज नथिंग, इट इज द correlation, yeah, it is the formation of equation between biological activity and the parameter of the molecule, properties of the molecule. You are going to correlate the biological activity with the properties of the molecule. तो ये जो correlation है, this correlation is good or not good, statistically suitable or non suitable. How you are going to say this correlation is statistically fit or suitable? So there are different statistical parameter. For this correlation, we have to calculate some statistical parameter that are called validation parameter for QSR. So we have to calculate some validation parameter. On that basis, we can say this correlation, this QSR model, this correlation is nothing. This is QSR modeling. We have to correlate this biological activity with properties. This is QSR modeling. तो in literature, suppose we are having a series of compound, and series of compound is having the biological activity, reported biological activity. That reported biological activity will be the observed one. If we have to calculate the theoretical value based on the QSR, so we have to put the values of this molecular MR, then log P. By putting the MR value, molar refractivity, and log P value, we will able to get the IC50 of that compound. This will be the theoretical biological activity from the QSR model. So this now we have to statistically validate this QSR model. Like in a linear equation, we are going to calculate the regression value, that is the regression for that line when the regression value r square value greater than 0.995. We can say that the equation is fit. Now we can apply, we can put the value of absorbance, and we will get the concentration. If the r square value lie below the 0.995, we can say that we can't use this linear equation for the prediction of unknown concentration. Like in QSR modeling, you have to correlate the biological activity with the different parameter of the molecule. Now you have correlated, but the what is the fitness of this correlation? You are going to calculate on the basis of this statistical validation. The application of statistical tool in validation of QSR model, I think you are able to get what is the validation and what is the QSR model. So there are different statistical tools which are applied to validate this QSR model. Validation is nothing. You are going to check the correlation between independent and dependent variable, that this correlation is statistically fit or not. So the first parameter is QA square. The formula will be 1 minus summation of y calculated and y observed divided by summation of y observed minus y average square is it is equal to 1 minus press value. The denominator value will be press and the numerator value will be SS. So previously I told that one will be the observed value and one will be the calculated. Observed value will be which is reported in the literature. You are having a set of the molecule. This is the set of molecule is called data set, and the activity of that data set is reported in the literature. And one is you are going to calculate based on that equation, based on that QSR equation. This is calculated. So you are having two value. One is calculated from the QSR model, that is calculated value for activity, and one is observed value that is reported in the literature. So this is difference between how you are going to calculate the QA square, difference of that calculated value and difference of that observed value for one molecule, and you have to and after taking the square you have to summation from the whole data set. Like suppose you are having the data set of 20 compounds. So minimum data set required for the QSR is 20 compounds. So you are having 20 compounds and then actual and predicted value for that 20 compounds. So you have to apply this formula for calculating the QA square. The value of QA square should be greater than 0.5. If we able to get the value of greater than 0.5, then we can see that the QSR model is predictive. Now this QSR model is fit to predict the activity of unknown compound, which properties are known. So on this multilinear equation, we will put the properties of the unknown compound and get the activity of that unknown compound based on the QSR model. This is one property, that is the cross-validated correlation coefficient Q square we can apply to validate the QSR model. The other thing is the correlation coefficient, that is R square. R square formula is 1 minus summation of y calculated minus y observed. When we fit the regression line, one is natural regression line and one is the fitted regression line. So this y will the calculated from the fitted regression line. So this y value minus observed value divided by y observed minus average value, we can get the correlation coefficient R. For a statistically fit QSR model, the R square value should be greater than 0.6 and difference between R square and Q square less than 0.3. Then the model will be statistically fit. Now we can say we can use this model to calculate the predicted value, calculate the activity value of an unknown compound. Another value is S, and next value is F. We can see the formula of S, summation of y observed minus y calculated divided by n minus 2. N is the number of data points here, number of compounds in a data set, and P is the probability value. So we can calculate the F test value and S value. S should be closer to 0. S should be closer to 0 means lesser value will be uh, good for the QSR model, and F value should be greater for a predictive QSR model. Yeah, statistically fit QSR model. Next, one more thing is the correlation. Correlation means in a multilinear regression, we can see that there are more than one dependent variable. Like here, we can see that x1 and x2 are more than one independent variable, and this is the log activity. This is the dependent variable which is going to depend on the x1 and x2. So if x1 and x2 denote the same thing, if suppose x1 says it is the electronic parameter of a compound and x2 says this is the electronic parameter of a compound. Like in previous multilinear example, we are having two independent variable. One was the temperature and other was the solubility. And we have to see the effect of temperature and solubility on the concentration. There was two independent variable, temperature and solubility. If suppose temperatures tell same thing and solubility tells same thing, then how you are going to correlate, how you are going to interpret that how much change would affect the concentration of the compound if temperature is same and solubility. Suppose this is not same thing. If I'm trying to say that the interpretation of temperature is same and solubility is same, both are saying same things, then how you are going to interpret this concentration, that how much dependence on temperature and how much dependence on this solubility. Like if x1 and x2 told same things, you are unable to interpret the variability of this activity on the x1 and x2. So the measure is to calculate the correlation. Means in a linear equation or in a QSR equation, the the independent variables should not be correlated. Means temperature should be temperature and solubility should be solubility. Temperature told a different thing and solubility told a different thing. So in case of QSR, the property which comes in a QSR equation, the independent variable which are obtained in QSR equation should not be correlated to each other. Means इनका जो correlation है वो नहीं होना चाहिए. Means आइडियल QSR के लिए इसका correlation 0.5 से कम होना चाहिए. जितना कम है उतना ही अच्छा इंटरप्रिटेशन होगा. Means you are not now able to interpret the activity dependence on the x1 and x2. So the dependent variable in a multilinear equation should not be correlated. So now we can able to get the idea of correlation in and its significance in case of multilinear equation or QSR equation. Another statistical tool which is most frequently used in our research, that is the t value. We can calculate the t value from the formula t is equal to x mean minus mu divided by s divided by under root, and x bar is equal to sample mean. Mu is the population mean under the null hypothesis. S is the sample standard deviation, and n is the sample size. T is the T statics. From one example, a pharmaceutical company claims that each tablet of pain relief drug contains 100 mg of active ingredient. To verify this claim, quality control analyst test 5 tablets and obtain the following drug content. Uh, he uh, he got the values 98, 101, 99, 100, and 102. At 5% significance level means 95% results are similar and 5% results are different. In a population of 100, 95% results are similar and 5% are different. 5% significance level, for 5% significance level, the p-value will be 0.05. So test whether the mean drug content of these tablet is significantly different from the labeled claim, that is the 100 mg. We have to test. This is true. The company is having true claim or it is not having the true claim. For that, we have to calculate the T statics. So firstly, we have to calculate the mean. The mean is 100 based on the 5 different data. The mean drug content is the 100. Now we have to calculate the standard deviation x minus x bar. X bar is the mean value. So on that basis, we have to calculate the x minus x bar value. X minus x bar square. Now we are able to get. Now we have to submit the x minus x bar ka whole square. The value will be 10. Now we are able to get the standard deviation. The value will be 1.58. Calculate the t value. X minus the claim value was 100, so then the mu value was 100, then average minus mu divided by s di divided by under root 5. T value is the 0, means there it is means there is no significant difference between the said value and the obtained value. We can say we can say that t value is the 0, so there is no significant difference between the sample mean and the label claim at the typical significance value. Example, p is equal to greater than 0.05. So we can say that if we get this data, we can statistically claim that the drug content in the tablet sample is 100 mg on the based on the this data. Next parameter is chi-square test. A chi-square test is used when you want to see if there is a relationship between two categorical variable. It was given by Carl Pearson. Suppose a tablet manufacturer claims that tablets in a batch are distributed by shape, 50% round shape and 30% oval and 20% are square. We get actually we get round 45, oval 35, and square 20. So we have to calculate that this claim is based on this data. This is statistically significant or not. So we have to calculate this is the null hypothesis. H naught means observed count match the claimed proportion. H1 observed count do not match the claimed proportion. We have to accept or reject the null hypothesis. Expected count, we have to calculate E, that is the total and the proportion. Round observed what 45 and oval observed what 35 and square was 20. Claimed was company was claiming 50% round tablet and oval 30% and square 20%. Then the expected will be 50, 30 and 20. 100 into proportion 0.5, 100 into proportion 30% का 0.3 हो गया और 20% का 0.2 हो गया. तो 50 ratio will be 50, 30 and 20. Chi square formula, chi square is equal to summation of O minus E square divided by E, O and E value. This is the observed and expected value. Based on this, the chi square value is equal to 1.33. Now we have to calculate the degree of freedom. Degree of freedom K, that was 3 type of observation, round, oval and square. So 3 or minus 1 degree of freedom is equal to 2. The critical value of P 0.05 at degree of freedom 2. So when at degree of freedom 2 and P value 0.05, the chi square was 5.99 and our calculated chi square was 1.33. This is the lesser than 5.0, 5.99. So we have failed to reject the null hypothesis. Then the observed tablet shape do not differ means our claim is right. It is do not significantly. Statistically हम कह सकते हैं कि जो हम क्लेम कर रहे हैं उसी के सिमिलर है. Now, one-way ANOVA. In one-way ANOVA, this is all we have. This is also a relation between dependent and independent variable. Here, a categorical independent variable. Independent variable is one, and a normally distributed interval dependent variable. और जो डिपेंडेंट वेरिएबल है वो इंटरवल डिपेंडेंट है लेकिन एक ही है. So we are now going to calculate the relationship between dependent and independent variable. Difference क्या है? आपको अप्लाई करना है एनालिसिस ऑफ वेरिएंस. किसके लिए? एक डिपेंडेंट और एक नॉर्मली डिस्ट्रीब्यूटेड इंटरवल डिपेंडेंट वेरिएबल, इनके बीच जो रिलेशन आया है अब वो स्टेटिस्टिकली फिट है या नहीं. तो वी हैव टू कैलकुलेट द एफ वैल्यू. एफ वैल्यू इज द variance, yeah, between groups and variance within the group. We have to take the ratio of this and we will get the value of f. Suppose we can elaborate this with the example of one beautiful example, that is the comparing mean cholesterol reduction across the type of statin. Suppose there are we perform the animal study in different group like that. Here we take 3 groups, group A, group B and group C. The researcher compare a mean cholesterol reduction after 8 weeks. The time is 0 point and 8 point. We have to calculate we have to compare the data at 8th week for 3 statin, that group 1, group 2 and group B and group C, group A, group B and group C. And each group we are having number of population 4. 4 patients are treated with each drug and the reduction are recorded below. For group A, first drug, 4 individual, reduction 12, 15, 14, 10. For group B, 8, 9, 7, 6. For group C, 20, 22, 19, 21. At the 5% significance value level, that is P value is equal to 0.05. Test whether the 3 statins have different matlab means you have to calculate the group A, group B and group C and tell that statistically the results are similar or different. So you have to apply the one-way ANOVA. What will be the formula? What will be the calculation behind this? You have to calculate basic sums and means. Number of groups K is equal to 3, number of sample size and 4 in which one group 4 into 3 is equal to 12. Sum and group means group A sum. So we have to calculate the group A sum and group A mean, group B sum, group B mean, group C sum, group B mean and grand mean. We have to calculate the mean of these through 51, 30 and 82 and divided by total sample will be 12, that is 163 and 12. The grand mean will be 13.58. Though Then variance between the group. So we have to calculate for this, we have to calculate sum of squares between the group, that is SSB. The formula will be SSB is equal to summation of n into xi minus x grand. After putting, after we are having the grand mean and individual mean and the square of the sum. By putting this value, we can able to get the variance between the group, that is the SSB value. This will be 343.166. Now we have to calculate the variance within the group, that is the SSW value. Now, we have to calculate this deviation for group A, deviation for group B, and deviation for group C, and we have to calculate the squared sum. Then SSW within the group, the value will be 24.75. Degree of freedom, mean square, and F static. Degree of freedom means there were between the groups देखें तो there were 3 groups. 3 minus 1, degree of freedom will be 3, and within the groups, that is n minus k, that is the 9. So we have to calculate the degree of freedom between the group and within the group. The degree of freedom between the group will be 2, and the degree of freedom within the group will be 9. Then mean square, MSB formula SSB divided by degree of freedom between, and MSW formula degree of freedom between divided by degree of freedom within. So you are having all the values. By putting these value, we are able to calculate MSB and MSW. Now we have to calculate the value of F. F will be the MSB divided by MSW. We are now able to calculate the F statics. The value will be 62.21. We can see the F value is far larger the critical value. F value is far larger to the critical value. बहुत ज़्यादा means we have to reject the null hypothesis that all 3 groups are not similar. If the value will be lesser than 0.05, it will be significant, but it is not significant value. It is far greater. So we have to reject the null hypothesis. Means this now statistically we can say the reduction in A, B, C group are not comparable. Means all 3 drugs are not showing the same reduction, same statistically same reduction या statistical treatment अगर compare करें तो वो comparable नहीं है for all 3 treatments. Then factorial ANOVA. In this case, in our previous case, we are having one independent variable, and in this like 2 ANOVA and factorial आप apply कर सकते हैं, लेकिन प्रेफरेबली भी यूज करते हैं 2 ANOVA. तो 2 ANOVA, 2 or more independent variable. We are having now independent variable 2 or more, and a single normally distributed interval dependent variable. For this case, we have to apply factorial ANOVA. Like we are having 2 independent variable, then we have to apply 2-way ANOVA. Suppose we are a researcher wants to study 2 groups A and B and 2 doses low and high to assess their blood pressure reduction. So dependent variable here is the blood pressure reduction, and there are 2 doses for group A low and high, for group B low and high. Patient 1, patient 2, this is the reading at low and high dose. So drug A and B dose low and high. So dependent variable is one, that is the blood pressure reduction, and we are having 2 independent variable. So we have to apply the 2-way ANOVA. Compute group means drug A B B dose low high है, mean reduction कितना हुआ 5 प्लस 6, यहाँ देखेंगे दो पेशेंट के लिए लिया था, पेशेंट 1 एंड पेशेंट 2, तो 5 प्लस 6 डिवाइडेड बाई 2, इन 8 प्लस 9 डिवाइडेड बाई 2, 4 प्लस डिवाइडेड बाई 2, 7 प्लस 8 डिवाइडेड बाई 2, तो दिस इज द मीन रिडक्शन. Then analyze main effect of the drug, compare overall mean for A versus B. Mean of A, that is 5.5 plus 8.5. This is the value 5.5 and 8.5 divided by 2. The value is 7. Mean of B 4.5 plus 7.5, the value is 6. Main effect of dose, compare overall mean. Now we are going to calculate the effect of dose. First one was the effect of drug, now the effect of dose. There were two doses, low and high. So what was the effect of low dose? That was 5.5 plus 4.5 divided by 2, and the value is 5. What was the effect of high dose? That was 8.5 plus 7.5, that is divided by 2, that is the 8. Check the interaction effect. Means there is any interaction effect of the dose and drug. For this difference of drug A, low and high, we have to calculate the value 8.5 and 5.5. We have to minus these values. The value is 3. Difference of for drug of B, that is the 7.5 and minus 4.5. The value is 3. Since difference are equal, अब equal है इसका मतलब है कि इनका कोई इंट्रैक्शन नहीं है. डोज और ड्रग और डोज, इन दो वेरिएबल्स के बीच कोई इंट्रैक्शन नहीं है. अगर इंट्रैक्शन होता तो डिपेंडेंस वैल्यू आ जाती, अलग अलग वैल्यू होती, मींस उनका इंट्रैक्शन होता. इस केस में कोई इंट्रैक्शन नहीं है. So up now we are going to check the statistical test. Use 2 ANOVA to calculate F value for main effect of the drug, interaction effect means drug or dose, drug versus dose. Compare F value with the critical F at alpha level of significance 0.05. Significant F, if we get the significant value F, then we have to reject the null hypothesis. Interpretation, dose has a significant effect on the blood pressure reduction, as drug type has a smaller effect, as no interaction between drug and dose type. This is the, now next parameter is the p value. P value is the probability of obtaining a result at least as extreme as the observed data. This is the use in statistical hypothesis testing to decide whether to reject null hypothesis. A low p value, commonly less than 0.05, suggests strong evidence against the null hypothesis and supports the alternative hypothesis. If the value is lesser than 0.05, we can say that the comparable value was similar, means the results are statistically significant. If the p value is greater than 0.05, we can say the results are not statistically significant, means there is no difference between the selected population, between the results. Or if p value is lesser than 0.05, we can say there is a significant difference between the comparable value. There are different significance level like p value 0.05, 0.01, 0.001, 0.001. The 0.0001 is the highest level of significance. We can say there is a excellent difference between the comparable population or comparable result. A researcher claims that a new drug reduces blood pressure by an average of 10 mg, 10 mmHg. You test it on 5 patients. Then there are 5% and data for the blood pressure reduction 12, 9, 11, 8 and 10. The null hypothesis, mu value 10, average reduction is 10. We have to calculate the average value. Average value is the 10. Then the we can say for this data, the average value is 10. Alternate hypothesis, if we have to reject the null hypothesis if average reduction is not 10 mg. Calculate the mean. Mean value is 10. and the sample standard deviation S value. I have omitted the formula of S, directly write the value of S. This is the because I have applied previously this formula, the value of S is equal to 1.58. The value of T is equal to 0. This is the previous equation I have elaborated. From this equation, the expected value is the 10. So we have to put the mu value 10 and the average value is the 10. Now we can get the value. T value is the 0. Find P value using T distribution curve. Degree of freedom is 4. That is the N number of population are the 5. Then 5 minus 1 degree of freedom will be the 4. For two-tailed test, P value will be the 1 by applying the formula, previous formula. Then we can see that this P value is greater than 0.05. We have to reject the null hypothesis. Means the data are not having significant. So we can say that there is no evidence that the drug reduces blood pressure by more than 10 mg. Large p-value, that is greater than 0.05, data is consistent with the null hypothesis. Do not reject the null hypothesis. And small p-value lesser than 0.05, data is unlikely under the null hypothesis, which rejects the H naught. So I have omitted the post set test which are applied after the ANOVA for the comparison of the data for between the group, within the group at different time interval. So I have omitted this from this lecture. That is a different topic and it will take more time. So at this point, there are number of statistical software available from which you can calculate these values. There is a SPSS. This is a paid software. R. You can use R. You can freely download this. There is a SAS, and this is a Prism. Prism, number of ecology people using Prism to calculate the to interpret the animal study data. There is a Minitab. This is a statistical software, and MAT lab we can you can also use. So you can use the evaluation of version of this software. As R is freely available, you can download this. SPSS, you can take the evaluation version, and Prism, you can take the evaluation version. Likewise, Minitab and MAT lab you can use. I think from this lecture, you are able to interpret this a statistical tool you can apply in your research in different domain, including QSR and in the interpretation of your biological and other results. So thank you, everyone.
Thank you so much, sir. As we come to the conclusion of today's expert lecture, I would like to extend my sincere gratitude to Dr. Sant Kumar Verma, sir, for delivering such an insightful and informative session. Sir beautifully explained the core of statistical tools like mean, median, mode, standard deviation, regression, also about the applications of the statistical tools in validation of QSAR models, factorial ANOVA p-values, and at last the statistical tools in the research. The way he simplified the complex concepts and connected them to real world examples truly enhanced our understanding and appreciation of the role of statistics in significant interpretation. Thank you so much, sir, for sharing your valuable time, knowledge, and expertise with us today. Your session has been indeed added great value to our learning. Thank you once again for gracing this session with your presence and wisdom.
So I at last I wish to thank Amar Sahid Baba, Ajit Singh, Jujhar Singh Memorial College of Pharmacy, BELA, for inviting me for this Golden Jubilee celebration and giving me chance to be a part of 51 online lecture series. I wish to thank the director Sailesh Sharma sir for his kind invitation. Thank you whole COPBELA family. And I wish to thank ISF CPU also. Thank you, everyone.
Welcome, sir.
Madam, may I leave?
Yes, sir.
Thank you, ma'am.
Yes.